Welcome to your first video on position, velocity, and acceleration. Position refers to the location of an object with respect to an origin, and who gets to pick the origin in this class? You do, because you're important. Now it has both magnitude and direction, and is therefore a vector. What this means is it's not enough just to say 5 meters. You have to say 5 meters yonder. It doesn't have to be yonder. Normally in one dimension, we will just use plus and minus, where the negative is equal to not. So if positive is right, negative is not right. Primarily, we will also use this term called displacement, which is delta x, change in position. And it's independent coordinate system, which means no matter who's looking at it, you're going to get the same answer. So let's talk about the relationship between velocity now. So we're going to talk about instantaneous velocity first. And instantaneous velocity is just the change in position over change in time at an instant. It's a vector quantity, so you can change speed or direction. So if I'm looking at this graph of position, I know that it's the derivative, or the slope. So let's work this with some math. Here's my dx dt. Let's employ the definition of velocity. Dx dt, take the time derivative of this. Time derivative of that's easy, that's 0. dt of t, well look, that's just 3 meters per second. And implicitly, that is positive. Let's say we want to go backwards now, and we want to find position. Well, position is just the area under this curve, which means calculus, which means integrate. Whew. So we'll start with this formula, and we'll use our definition of velocity. Let's move this dt over to this side. So we moved the dt over here, and now we'll just integrate all of this from our initial and final positions and our initial and final times. Carry this through, plug in our final and initial values. Yay, math. Now, if you're looking at an average, this is just total delta x, your total displacement over your total time. All you care about when you're looking at an average is where you start and where you end. You do not care what happens in the middle. But velocity can change as well. So let's look at acceleration. So it's a change in velocity, which means if your speed, that would be your magnitude, or your direction, maybe you're turning. Both of those are accelerations. Instantaneous acceleration is your instantaneous change in velocity, your derivative, or your slope. So if I'm looking at this curve, I want to find my change in velocity. Well, that's just going to be the area under this curve, which again, you're thinking calculus and integrate. This time our velocity is a function of x. Well, that doesn't change the definition of acceleration. So let's take the time derivative. d dt of just the velocity. So change in time derivative here gives you acceleration. Change in time derivative on this side, it has this x, but this x is time dependent. So it doesn't just disappear, it goes right here. And I'm going to put big yellow lines because this step is really important. It's easy to forget about this, and I see it all the time. So please remember that x is time dependent. I apologize for my handwriting. So we'll plug this in. Oh look, dx dt. Well, we know what that is. It's just velocity. So we plug this. Goes down to velocity. Plug in our initial function for velocity, and if I had some initial position, I could tell you it's acceleration. Now, just like we had velocity, average acceleration, this is just going to be your total change in velocity over your total change in time. Again, all you care about is where you ended and where you started. Couple conceptual notes. If you're moving this way, and that's your v, but your acceleration is this way, remember, acceleration is delta v. After some time interval, your new velocity would just be this much shorter. So this would be our new velocity. It changed. You're going in the other way. So if you were moving 5 meters per second, now you're moving, say, 3 meters per second to the right. So let's jump off a diving board. Not literally, but let's pretend. So our velocity is pointing down. Which way is your acceleration as you come to a stop? Pause, think. Okay, good. I'm assuming you've paused, you've thought. And then our acceleration is, of course, going upward because we're going to end up going down to 0. This is just that last piece in words. Speed is decreasing, velocity and acceleration must have opposite directions, and therefore the direction of your acceleration is upwards. I hope this was helpful. I will look forward to seeing you in class.